Now we're going to be talking about Entity Framework Core. In this module, we'll talk about creating entities, using the DB context to allow us to query entities in a data store, seeding and creating the databases, using a repository pattern, and logging. Entity Framework Core is the library we're going to be using for all of this. It's a complete rewrite of the earlier version of Entity Framework that was used in the .NET Framework. One of the big changes is it removes the requirement that the data stores you're going after are simply relational. Like the rest of ASP.NET Core, it's completely open source. And there is a version now in .NET Core 3 of the older Entity Framework 6. Mostly this is so you can interrupt with existing .NET Framework apps. For the most part, they're not putting a lot of energy into adding new features here, and would suggest that for new development that you use Entity Framework Core. Let's get started. So now let's take a look at creating entities and even a DB context to access data in a data store. Back in Visual Studio, let's first create a couple of directories. We're going to create a directory called data that will contain the classes for our different interfaces to the database. And underneath it, I'm going to create a directory called entities, and that's going to contain the classes that represent the shapes of the data we want to store in a database. Now, I've pre-built these entity classes for you because there's a few of them and I didn't want to spend a lot of time talking about how they're built. But let's first go get them. If you add some existing files to the entities folder, you're going to want to go into a directory called resources. You can get these resources by going to the GitHub repository at github.com /author building ASP.NET Core 2. In this directory, you'll see a resources folder, and you can decide to just download the entire folder as a zip file so that you have access to the resources I'll need. And you don't even need to create a GitHub account to do this. Once we have the resources folder, just go to that folder, and we're going to pick order, order item, and products.cs to add to this folder. And let me walk through these very briefly. So the product is the list of properties about a product that we're going to store in a database. Category, size, price, etc. We also have IDs, and these IDs represent the primary key that you're going to use in the database. For us, we're just going to use auto-numbered IDs, though you can also store this as GUIDs and other ways using Entity Framework Core. But for us, we're going to use auto-incremented IDs, and so we can just name the field ID. The way this is going to work with Entity Framework Core is it's going to take each of these properties, the names of them, as well as the data type, and create the corresponding field in a table inside of SQL Server in our example, though it could do the same thing in other databases as well, whether they were relational or not. If we go ahead and look at the order, we'll see one that's a little bit more complex even though it has fewer fields. It also has this auto-incremented number like we did in the products, but it also supports a collection. This is a way that we can relate one entity to another entity. In this case, we're saying that there's a relationship between the order and the order items, and that is a parent-child relationship or a one-to-many relationship. By specifying iCollection in here, when we create the database, it's going to create that relationship between the two items. And then finally, order item itself has again that auto-numbered ID, some properties that are going to be important to us, and relationships to the product and to the order it belongs to. And again, because the property type here is an entity, Entity Framework Core will treat that as a relationship between the order item table and the product table, as well as from the order item table to the order table. Now, depending on what database you're going to be using, this relationship can be modeled in a number of different ways. But we'll see what this looks like when we actually attach this to SQL Server. So essentially what these three classes are doing inside the entities is we're using them to define the shape of the data or the models that we're going to use to actually store data inside some data store. Now that we have the entities in place, we're going to need the Entity Framework core package. We'll go back to dependencies and just say manage NuGet packages. We're going to search for Microsoft Entity Framework core. And we're going to see a number of different packages here for Entity Framework core. I'm not going to belabor all of them, but because we're going to be using SQL Server, we actually want the core SQL Server project here. This will include this Entity Framework core base package for us. If you're working with .NET Core 5, you're going to want to probably pick the latest version, or if you're eventually using .NET 6. If you're using an older one, you're going to want to pick one that matches, like 3.1.12 right now is the current version for .NET Core 3.1 instead. But we're working with 5 in our examples, so let's go ahead and include SQL Server. I'm going to ask you to agree for all these other packages that it actually is going to use. I would say accept. There's one more package you're going to want here, and that is the design package for Entity Framework Core. This is a package that's required when we're using the Entity Framework tooling to do things like update and create databases. So let's install that as well. And that's a much simpler package. Now that that's installed, let's create a context class. So in the data folder, let's create a class that I want to call Dutch context. The word context from here comes from the fact that we're going to derive from DB context. DB context exists in Microsoft Entity Framework core namespace, and it represents a class that will know how to execute queries to a data store. In order to create these queryable endpoints, we need to create some properties that will allow us to get at the different entities. These properties are going to be of type dbSet, and then the type of entity. So if I go ahead and say dbSet of product, let's bring in the namespace briefly, and then I'm just going to call it products, usually the plural of the type. Once we craft up a Dutch context, we'll be able to issue queries against the products or even add products to the database. The other one of these that we're going to want is a dbSet for orders. Now, instinctually, you might think we want to create one for order item as well, and you can. That would be optional. But because orders has a relationship to order items, unless we want to query the order items across orders, we don't actually need it. If you want to think about the way you use your entities, we're probably only going to be worried about order items as a child of orders, that we're never going to be looking at them across an entire spectrum. So it's optional here to create one for DB order item, but we're not going to need it. So I'm going to omit it. I would only create DB sets for things you want to query directly against. And because I'll always be getting order items only when I get the containing order, I'm not going to bother with a DB set for order item. Let's just do a quick build to make sure we've included everything. Nothing should be working yet, but we should at least be able to build as we get closer to being able to use this Dutch context. Since the build worked, succeeded, we can go on. Let's next talk about the Entity Framework tooling that we're going to use to build our database. So next, let's talk about Entity Framework core tooling. Over in Visual Studio, let's open up a console in the root of the project. And if you remember back to the earlier modules, we talked about .NET being the command to run different tools within ASP.NET Core. And if we do .NET --help or /h, we'll see a number of these SDK commands. These are commands that are built and included as part of the SDK when it's installed. What we're going to do first is ask it, based on our DB context, to create a database for us. Before we can use a tool to generate our database, we're going to actually need to include it. If we try to do .NET EF, which is the command we're looking for, you'll actually see it says not found. And that's because, unlike early versions of .NET Core, the EF tools aren't installed by default. We can install them with our project or globally. And the installation's pretty much the same. We can say .NET tool install .NET EF is the name of the project, and if we include a -G, it will do it globally, or we can just do it in every project that we're going to need it. For me, I'm going to go ahead and install it globally because I use it on a lot of projects. Now that it's installed, if I just do .NET EF -- help, we'll see the different commands it can do. It can do things with the database, DB context, and then handle migrations. So let's use it to create our database initially. So .NET and then EF, since we're going to use the EF tools, and then we're going to say database as the command inside the EF tools, and the subcommand here is just update. This is telling it to create and update a database if necessary that's going to match the data context that it finds in our project. And the error we're getting is this no database provider has been configured for this DB context. What does that mean? That means that we have a context that has entities associated with it, but we've never set it up to know what database to actually use. And that's an important concept with the way the Entity Framework Core works. And that is, a context isn't tied to a specific database. You could have the same context that can write to SQL Server, to MySQL, to a document store like Cosmos DB. The shapes in the DB context aren't limited just to a single database provider. But because of this, we have to tell it what database our project actually wants to use. So let's return to Visual Studio. So let's open up that startup. What we want to do here with the rest of our code is add a new set of services. And this is going to be adding the DB context. And we're going to specify the Dutch context type. You may need to add the namespace for that to work. And so now that we're including it, we come back and do .NET EF database update. We can see that it says no database provider has been configured. And while we added DB context to the startup, we're going to need to actually tell it which database we want to use. We can do that by adding a lambda here into the add DB context and using that configuration to say use SQL Server, which we'll need to bring in the namespace for. And using SQL Server, we'll tell it then that this is the database we want to use. So realize what this actually means. This means, hey, I could change this up so that in release and debug, we could actually be using different databases. You might imagine an in-memory database for testing and then an actual SQL Server for production. And back in the shell, let's repeat that command. And what it's showing you is that because we added this add DB context, we're going to need to create a special constructor for supporting this. And there's a couple ways to do this. We could go and support this, but the other way we can do this is actually go to our Dutch context and let's override, because we know that this is the context we want to a specific database, on configuring. This gives you an options builder that we can use to do the same thing. Use SQL Server to specify that. Let's go back again, and we get the last of the errors. I wanted you to really see how this structure works by showing you all these errors. But it says a relational store is configured that needs a connection string or a DB connection to start. And that's actually what we need here. We could put in here just a connection string. Server equals our machine, whatever. But we actually would like this to be configurable, because hard coding a connection string in your code is a bad idea. So let's do that next. So now let's add configuration to our system. Back in Visual Studio, you'll actually see an app settings and an app settings development.json file that already exist. And this is how configuration can work. We're actually going to delete them and create our own. This isn't something you would normally do. The app.configuration files are fine, but I want you to see what's really happening. And so we're going to do the hard work this first time. And what we're going to do is we're going to open up Program, and one of the options here on the host is to actually configure app configuration. Not the best worded method, but effectively what it's saying is I want to configure application configuration. And that is happening at startup. It's loading this configuration file to have things that can be changed. And so I'm just going to say add configuration as a name. And I'm going to use refactoring to go ahead and create a method that I can use here to just implement it. And I'm pretty much only doing this because I want to be able to see the code a little better. I could do it as an inline lambda as well, but it gets kind of busy. So I'm going to change these names to context and builder just so we can see what we're working with. First, let's get rid of all the existing providers. So don't have it look for the app configuration settings anymore. So the first thing we want to do here is actually go to the sources and clear them. I want to get rid of the need for the app configuration file and just have our configuration file be the master of it. Again, this part isn't necessary in your day-to-day development of ASP.NET, but I think it's useful to see this so that you can know how you can extend and create this. What we're going to do is actually say builder add, and we can see that there's a number of different kinds of files that can be used. Command line operations, environmental variables, INI files, JSON files, XML files, user secrets, etc. And this is a way for you to say, I want to get configuration from all sorts of things. In older versions of ASP.NET, we would use the web config file instead. And instead of having one file that's fixed to some format, this gives us flexibility to add a number of different sources so that it can be easier or harder to add that configuration. So let's start with just set our base path. And this base path is basically saying, what is the root directory for my configuration files? And in that case, I'm just going to say directory, and I'll bring in that namespace .current directory. And this is a fluent syntax, so we can then add our different files. And we're going to add a new JSON file called config.json. And we could be done with that. We could go ahead and create a new JSON file here, config.json, and put in all the settings we want. But I want this to be overridable, so I'm also going to do add environment variables. Why would I do that? Environment variables are useful in thinking when you go to production, if you're deploying with traditional IT people, setting environment variables that aren't rewritten every time you publish a new version, unlike config.json, might be useful. But this is especially useful when you start to deploying into cloud providers, because they use environment variables quite extensively to define different configuration pieces. And what this effectively does is builds a configuration based on what sources you're putting here, and order matters. So in this case, it's going to add json.file, but if environment variables also sets it, it's going to win. And so we can set up these rules by having the order of the configuration files read to override values. And so this becomes the development standard file, and then this becomes overrides that we need to use during production. A big case for that is a connection string, right? We're going to have development time connection strings that we're going to use in our program, maybe even check them into source control. But at production time, we're going to have someone who's responsible for pushing those projects out, set a connection string to a SQL server, including sometimes credentials that obviously we don't want to just be sitting here in our code, or even a configuration file. Now that we've done this, we can go ahead and look at that configuration file we created and just see what we want to do with it. And the way this works is it's a hierarchy. And so we could have favorite colors as a name value pair, right? There we have a color. We can go ahead and get it, and it can actually be used. For us, we're going to use a different one, which is we're going to say connection strings, which is a common name that's used a lot. And so it has this sort of conventional name of connection strings. And then we're going to call this our Dutch context DB. And here we want to go ahead and get some database connection string to put in here. If you're using Visual Studio, or if you have access to Visual Studio on Windows, you'll already have a couple of local DB servers installed. You can put any context you want in here, but we're going to use this local DB project v13 instance. And if we just click on it and look at the properties, we're going to actually see a connection string. It's grayed out, but we can click on it, select all, and copy it, and just paste it in here. Now, this isn't actually exactly what we want, but this is going to point at the data source, which is this server looking at something called Project v13. Initial catalog is going to be what we're going to call the database. In our case, we're going to call that Dutch treat DB. We're going to leave integrated security because for development, that's fine. We're going to leave a short connection timeout, and then the rest of this we're going to get rid of, because we don't need any of the rest of this pieces for our connection string, but we do need to add one more, and that is multiple active results sets equals true. This is a feature that will allow SQL Server to go ahead and get more result sets at once than just a single one. And for Entity Framework, this ends up being kind of important. Now that we have this set, how do we actually get at it? Let's talk about that. Let's go back to our context. And remember, we need the connection string here in our context. So what we can do is simply add a constructor. And as a requirement in that constructor, we can ask for an interface called iConfiguration. You may need to bring that in Microsoft extensions.configuration. And then we can just bring it in as a field, like we've done with other requirements. And then we can go ahead and use this. And how does this work? It has a few different ways of getting values, getting sections, those sorts of things. And there's two here. There's get connection string, and this assumes that you have a section called get connection strings. Or we can actually just use an array indexer here to give it the entire key. Now, how does the key work? We're dealing with a hierarchy. In our case, we could say connection strings colon Dutch treat DB. This colon is walking down the hierarchy. So if you have a deeply nested one, you'll have value colon, value colon, value colon, value. Again, just to see what this looks like, connection strings is the root object, and then Dutch context. In fact, I got it wrong. It's Dutch context is the name here, not Dutch treat. And it will read that and return it as a string by default. There are other ways to manipulate or pull in data from this connection string, from this configuration object. But we're just going to use the get simple strings in our course, because that's the most likely use case. And again, what this does is allows you to do arbitrary configuration inside your system. You no longer are listed in the old web config problem of app settings, where everything is just this flat, huge list of objects. You can have some structure to it, so it'll be easier for developers to find things and easier for production to manipulate or to override those settings. Now that we have this, if we go back to our shell, we can do that .NET EF database update, and what will happen? So we can see that it says no migrations were applied, the database is up to date, but what did that really do? We can see it created the database, and all it did was create an entry for this migration history table that it uses to know how to migrate from one version of a database schema to another. But how does that actually work? This term migrations is key. So if we come in here and do .NET EF, again, that's the subcommand, we're going to say migrations, and we're going to add a new migration called initial DB. So we have the schema that we've defined as those entities, and we're going to tell it to go ahead and create the initial database migration, which will create those tables based on that schema that's in our Entity Framework model. So it added them, and what does that mean? Over here we have a new migrations folder, and it has generated this code. And initial DB is where all of the changes to make the database. And so if we actually look at it, we'll see that it's creating a new table called orders, a new called product, and it's inferred all this information from those context classes. If we want to apply it, we can just say .NET EF database update, and it's going to look at that migration table and the latest migration we have in our folder, and it's going to apply it. Notice it's applied that specific migration, and we can see our date in here. I recorded this on the 18th of February. You can actually move this migration folder. I'm actually going to move it into data just to clean up our root namespace here, because we're not going to use it a whole lot. But now that we've applied those migrations, back here we can see we now have tables for each of those entity types. And not only tables, but also foreign keys, primary keys, etc., that apply themselves to a schema that is going to infer what you had in those entity tables. And so if you're not as familiar with database systems, this may be an easy way to start storing your data without having to understand all of those rules. If you understand databases and schemas really well, you may want to just craft your entities to look up data in the database separately than using migrations. But this is a scheme that's awfully helpful. So now that the migration is done, let's go ahead and start using our DB context class. So now let's use the DB context class in our projects. Back in Visual Studio, I'm going to make this a little smaller again. And I'm going to actually close all the documents just to make it a little cleaner. In our controllers, I'm going to load up that app controller class. And I'm going to create a brand new action called shop. This will be our shopping page for users. What I really like to do here is in the view, show some products. We're going to make this a little better as we go along, but I'm going to start by actually querying the database for all the products and setting them on the shop page. So before I can do that, I need access to that Dutch context class. So let's bring in the namespace for data, and then I'm going to simply initialize a field for my Dutch context and store it. That way here I can just say results equals context products to list. This will go to the database, get all the products, and return them. But I might want to actually do some querying on them. So let's, using the Fluent syntax, let's add an order by. This will take a small lambda to do the order by. Let's order them by category. We could certainly also do this directly with a link query if you would prefer that syntax. We can say from p in context.products, order by p.category, select p. And this would actually be the query itself, and then in view, we can call that toList. So whichever format you like to use, the Fluent syntax or the actual link query, this will work in pretty much the same way. So one thing you'll notice that we haven't really done before is we're passing data over to the view. This is one of the concepts inside Model View Controller inside of ASP.NET Core that is important. So we're going to do any logic we need here. In this case, we're just ordering some data, and then we're passing it into the view. Let's go ahead and make the view so we can make use of this data we're passing in. So we go over to Views App. Let's create a shop.cshtml file. And the first thing we want to do is actually specify the model for the page. The model is going to be the shape of the data that we're using on this page. So this app controller is actually returning here a list of products. So we can actually do the same thing. We can say list, or I actually prefer to say enumerable product. And in our case, we're going to need to either put the entire namespace here, or if you remember earlier, we added controllers and view models to our using statements. Let's go ahead and add data.entities, since that might be a common type of model we're going to use. So we now have the model specified. And the benefit of putting the model here, though it's not necessary, is that we're going to get IntelliSense on our project. So we could do things like saying, first put an H1 for shop, and then we could just make a little count is at model. Notice it is in capital letters. And this model is going to represent what? The enumerable product that was passed in. And I could just say count, because this enumerable is going to allow me to show that count. We could also use a for each product in the model. Let's go ahead and just create a list item with p.title. Now notice when I did p dot, because it knows the type because of the app model, we're going to get IntelliSense. If we don't include the model here, it's actually continue to work, except the model ends up being dynamic, and you're going to hope that you're not going to get runtime errors. By having the model declaration here, we're going to guarantee that at authoring time, that at least we're using the right names of fields and things like that. So let's go to the shop page and see this actual work in practice. I'm going to launch it here in the browser. If we go to our shop page, which we haven't actually put anywhere on the menu yet, we'll see that we get the shop, but no products are offered. The reason for that is we need to seed the database with some example data. Let's do that next. Next, let's create some sample data and seed our database with that data. So starting with 2.1, Entity Framework Core supports a way of doing seeding of data you might want in a new database. It does this as part of the migrations. So let me show you what this looks like. If we open up the Dutch context, we can override the on-model creating. This method, on-model creating, is where you can specify how the mapping is going to happen between your entities and the actual database. For example, we're not actually going to make any of those changes. Let me show you what I mean. You can take the model builder here and specify for a specific entity, and I'll say product in our case, that we want to say property for product title has a max length of, let's say, 50. And so you can use this to specify different properties about the model when it creates it. And these are actually used by the migrations when it builds them. But we're not going to use that here. Instead, we're going to use it for has data. Has data is going to allow us to add some default or seeded data to our model. And it does that by embedding it into the migration. So let me give you an example. If we look at the entity order, we can say has data equals a new order, and let's just build up an order here. ID equals 1, order date equals date, time, UTC now, order number equals 1, 2, 3, 4, 5. And by using this has data functionality, if we open up a command window and just say .NET EF migrations add seed data, and we come back here to our migrations, we'll actually see this seed data show up in our migrations. And if we look at it, one of the things it's going to do here is it's going to say insert data, and then here are the values of the data, just like we had specified. Now, the problem with this is this works great for really simple cases like adding an order. Once we start getting into related data, like adding the order items, we need to start to change the way our model looks in order to make those relationships happen. Entity Framework Core 2.1 is the first time they've introduced this idea of has data, so I'm not surprised that it has some limitations right now. We're going to use this just for our order, and then later when we need to add all of our products, because it's a more complex sort of idea, we're going to do it in a different way. So I suggest that has data is great for simple lookup. So you can imagine if you had a country or a state lookup table in the database, that this would be a perfect place to do that. But when we look at needing to create dummy data or large amounts of data, like we're going to do by creating a full product list, we don't actually want to do it on model creating, because all of this code is generated every time you new up a new Dutch context. We'd like to have a way of doing it that doesn't really impact our runtime performance. Back in Visual Studio, I'm going to create a new class called Dutch Seeder. In order to seed the database, we're going to need to be able to save or read data from the Dutch context. So I'm going to create a constructor that takes a Dutch context and just creates a field for it, just like we've done a bunch before. And we're going to create a simple method called seed. What we want to do in seed is actually build up a bunch of products and maybe create one simple order. But before we do that, we need to do two things. We need to first check with the database, and on the context there's an object called database, and here we can call ensure created. And what this will do is make sure that before we try to issue any queries, which we'll do in a minute, we want to make sure the database actually exists. This just simplifies the ability to make the query without getting crazy exception about the database doesn't even have that table. Once we've ensured that the database is created, and this isn't going to create it in every case, it's only going to create it if it doesn't exist. That's why it's called ensure created. We're just going to check to see that the context, and let's use products as an example, any. So what this call to any does is return true if there are any products in the database. This is in essence a tiny little query that says select count of products, and as long as the count is greater than 0, return true. And what we're going to actually want to do is say if there aren't any products, then we need to create sample data. Now, the seeder, or some class that can create this default data, is pretty useful in development, but can also be useful for building up lookup information. You can imagine if you had a state table filling in all the U.S. states, or certainly country table filling out all the countries of the world, that sort of lookup data that's not necessarily going to change over time, you might want to use the same mechanism for creating. So now what we're going to want to do is get the JSON that is that art.json file. And so we're going to use file.readAllText in order to do that. But here we need a file path of some sort, right? And we can assume that we have a file path of data/, art.json. But that's not going to work right. It's not going to know where this actually begins. So what we want to do is actually say path.combine. We want to add the beginning of what this should be. And where do we get that? We're going to need to bring in an interface called iWebHostEnvironment. And I'll just call that env for short. And this is going to tell us information about the environment that we're running in. Because again, we're loading this in at runtime. And so with that env, you can actually ask for content root or web root. Web root's going to get you the www root folder for you to get web-related things. So for us, we're going to actually look at content path. And we can combine these two strings into this. And now we need to get actually the items in it. So we're going to say our products are going to be, and we want to use some way of reading these objects. We're going to do this with a JSON serializer class. This JSON serializer is part of system.text JSON serialization that's built in. And we're going to want to say deserialize, and then we're going to give it a type that we want to create it. Now that type is going to be an IEnumerable because it's a collection. And what is a collection of? Product, right? Because this art.json matches the structure of our product class. So we can tell it to deserialize it directly in there by just saying JSON. Now that we have the products, we can go ahead and add them to the context. We do that by using the context and just saying add range. We're using add range because we have a collection of these products. So let's go ahead and just put products in there. We can specify to make sure we know where we're adding them by saying products.addRange. This doesn't get saved until we actually tell the context to save the data. In this case, we're going to use context.saveChanges to do that. But we also might like other data that's related to this. So let's go ahead and get the first product. Let's go ahead and create a new order. And let's just fill in some of the data there using the object creation syntax. So I'll say order date is going to be date time today. Order number is going to be, let's say, 10,000. And we can leave the ID at 0. The database will fix it up for us. But we might want to have our items set. And let's create a new list of order items for that collection of items so that we can add an order item here as well. Again, using that object syntax, I'm just going to create a new order item. And what am I going to do? I'm going to say the product that I'm ordering, it's just going to be products.first, right? Just that first product that is in our list. And then the quantity, let's go ahead and say 5. And then the unit price, let's go ahead and get it from products.first.price. Right? We're not going to increase or decrease that price. And so we now have an object that represents an order that we can then use the context to also save. And here we're going to say add because we're only adding one. But notice we're adding not only the order, but the related order item at the same time. And the save changes will not only just put them in the database, it will make sure that all the primary keys line up. So when we say this is our first product, it's going to take the ID here and put it in that foreign key column for us. When we say that order has a collection of order items, it's going to use that to take the new primary key of order item and stick it into the foreign key of the mapping table between order and order items for us. So now that we have that, let's go ahead and figure out how to run this. And the trick there is to actually go to program.cs. Earlier versions of this course, as well as some other people, have mentioned that the best way to do this is actually in startup. But what we've learned is we actually want the seeding to happen way before we set up the web server. So the trick here is to actually get the web host by still calling build web host. That's perfectly fine. But we're going to run the host later. What we actually want to do here is instantiate and build up the seeder. So what I'm going to do is I'm just going to call a method that says run seeding. And I'm going to actually pass in the host because the host has some helpful utility for us. So I'm going to just go ahead and create a quick method for that, just so we have it isolated. It's not super important that we do it in this way. And we're going to want to do a couple of things. We're going to first want to get our seeder object itself. We can do that by calling host services. This is the services object that the web host has already set up via the startup class. We can just say get service. And what do we want here? We want the Dutch seeder. Bring in that namespace. And in order to use the generic version of this, we're actually going to need using Microsoft extensions dot dependency injection. And so we can get the seeder, and we can certainly call seeder dot seed, right? Well, it's not quite as simple as that, because what the get service does here is it creates an instance and tries to fulfill all of its dependencies. So before we can do this, we actually have to go into startup and register. So services, add, let's say transient, because that makes the most sense, and make sure we have our Dutch seeder here as a type that is going to be creatable through the dependency injection or the service layer. Back here in run seeding, this might work now, but in order to really bulletproof it, we have to realize that Dutch seeder actually contains scoped dependencies. And how do we know that? Here in startup, our add DB context here actually creates it as a scoped service. It's not immediately apparent here that that's the case, but it is the case. And so because of that, we're going to need another class called a scope factory. This is a way outside of the standard web server to create a scope. And what's interesting about this is that during every request, the scope factory actually creates a scope for the lifetime of the request. That's why you get an instance of that context object that is true throughout an entire request. But outside of that, there isn't a default scope unless we create one. And so we'll do this by calling host services get service, just like we did before, and it's called service scope factory. With this new scope factory, we can just say using scope equals scope factory dot create scope. And we're using a using keyword here so that the scope is closed once our work is done. Now that we've created the scope, we just need to change the seeder here to get the service from inside the scope. So instead of actually looking at the host services, we're going to say scope dot service provider and get service Dutch seeder. It's the same, but we're telling it to get it within the context of the scope. So in this way, we can see that in main, we can tell it to run the seeding every time we run this. So guarantee that as we run our program, that we go ahead and execute that seeding. And of course, because the seeder is checking to see whether the products were loaded, it will go ahead and only seed it if the products haven't been already there. So this ends up being pretty quick. But as an alternative, because I actually like this a little better, is we can actually wrap this in a quick if. So if we look at the arguments, and we want to make sure that it has one argument, and we want to go ahead and check that that first argument to lower actually equals the seed argument we want to give it. Now we could make the argument handling a lot more structured here, but effectively we're saying if we say seed, we don't want to run the actual hosting, we just want to run the seeding. So if it's seed, run the seeding, otherwise don't run the host. Otherwise run the host instead, so you can listen. And so if we run the seeding, we'll see it says it built, it ran, we don't have any debugging information in there, so it didn't show any of the console. But if we now look at our SQL Server products, let's view the data for those products, you'll see all those 24 products were actually added in there for you. And so the seeding worked. And opening up our app controller, and I'm just going to use our new context to see if we're actually getting the products. So I'll say Dutch context as a new parameter of our app controller. I'll call it CTX. And let's go ahead and include the namespace, and then I'll go ahead and create a field for it. That way down here, we can go ahead and use it. And I'll just say, go ahead and get all the products, or more interestingly, just to list. Now let's set a breakpoint here, just so we can see if this is actually working. If we come down here, we can now see the results from the products is 800. That means the seeder actually worked. It actually instantiated it as part of that startup process. So now let's look at the repository pattern. Back in Visual Studio, I'm going to create a new class inside the data folder called Dutch repository. And in this class, I'm going to inject the Dutch context. The Dutch context, and then I'm going to just create a field so we can get at it. And I want to create a couple of calls that return data. So I'm going to say an INumerable list of product. Let's add that as entities, and I'll say get all products. And then I can just use the context to return them. Now here I might decide to sort them or even filter them in some cases. So let's go ahead and just use a order by. We'll say order by title, and then we'll just call toList. So this will very easily just get a list of all the products. Let's add one more, also returning products. Get products by category. And in this case, we'll ask the user of this API to pass us in the category that they want. And we'll just use the context to get the products again. But this time we'll put in a where so that category is equal to the category to list. So here we have a very simple API for getting data. And so the repository that we're going to create, their job is really to expose the different calls to the database that we want. And we're going to do this by actually exposing or implementing an interface. So we're going to extract an interface from the Dutch repository. And you see it's calling it i.repository, which I'm happy with. And I'm just going to include all the members we created into this public interface. The reason we want the interface is that when we're doing testing, we may want to create a mock version of this that returns static data or maybe data from an in-memory database or something that is easy to mock up so we're not testing against the actual database. And so this gives us a couple of things. One, it gives us the ability to define what all the queries look like in one place so that we can test them effectively, but it also makes it easier to figure out what the queries are actually doing. Some people like to create repositories that are based on generics. So it might say get all and then have a generic where you would pass in a product or an order, and you can actually implement that. But you start to lose the benefit of the testing surface because constructing a mock version of a generic interface so that it returns products when you ask for products and orders when you ask for orders ends up being way more complicated than it should be. And so I'm of the opinion that repositories should be pretty simple. Often we'll want to add a new piece to the repository, like I'll add save all. And in this case, we can just call save changes greater than 0 because save changes returns the number of rows affected. So a save actually worked if the number of rows affected was more than 0. And I'll just return that to have that save all. Now I've created it in the Dutch repository, but it's not here in the interface, and so I end up having to create it in both places. Usually what I do is I'll create it here in the interface and then just ask Visual Studio to implement the method that I'll fill in the body for. We'll see that happen a bunch of times as we continue through the course. Let's register the repository with the service layer so we can actually use it. Let's go to Startup. And let's just down here, let's say services.add, and I'm going to make it scoped because I want the repository to be shared within one complete scope. So this is usually a request for most of the code we're going to be writing. But this way, you're not constructing them over and over again. You're actually going to reuse it through a scope, and then it'll be deconstructed as necessary. So here, I'm going to say add scoped, and I'm going to use the interface first. Dutch repository, and then say Dutch repository. What this is actually doing is saying add Dutch repository as a service people can use, but uses the implementation this version. So you could imagine in a testing project, I might say a mock Dutch repository that I build that just returns some static data. But we're not going to go through that in this course. We just don't have time. Now that we've added it to the service collection, let's go back up to our controllers. And let's replace the Dutch context here with Dutch repository. And in this case, I'll just implement the field like we've done before, and let's get rid of the context. Since we don't want to use it directly, we want to make our calls through the repository. So down here in the one call where we're using it, instead of calling the query directly, we're just going to say repository get all products. We'll get rid of the toList because it's not necessary anymore since this get all products actually returns the enumerable list of products. And if we run this and go to our shop page, we should see now we have all of the different products still, and we're getting the same list of products, though ordered a little differently than we were before, but we're going through that separate level of indirection. Next, let's format this to show our list of products better. So now let's show the products in a better way. In order to make this look better, we actually are going to go back to the index.cshtml, and let's just go ahead and grab this example we had earlier, right? This looked sort of like what we wanted it to. We were formatting it with some custom CSS, which we aren't using anymore. So back here in the shop, let's just go ahead and paste that in. And in that case, for each one of those, it's going to try to create one of these. And in fact, if we do nothing, we're going to see these mugs show up all across the land. But this isn't quite what we want. What we'd like to do is actually just wrap this whole thing in a div that's going to give us some sizing. So let's go ahead and use the column sizing we have before, column medium 3, in order to create 4 of these across so that we have some distinct sizing there. If we refresh the page again, we'll see that they're now all together, but they're still not giving us 4 across. And the reason for that is that the column values really only work normally when they're inside of a row. So we want to take all the generation of the 800 of these and put them inside a div with the class of row. Now these rows are interesting because even if the whole page becomes smaller later, it's still going to treat what's inside this row as a grid of 12. And so in that way you can nest these if you need to, but that's not really what we're talking about yet. By making the row, we can now see we're getting these 800, but of course we have all the same data over and over and over again, probably not what we really want. Now we can start to put the real data in here. So let's start with what's in this H3. Let's go ahead and use Razor to go ahead and put the category here, and then the size here. We're getting that IntelliSense because of the model up here, and so we can continue down through all of these. And because we've gotten rid of the classes, let's go ahead and get rid of any extra classes that are included here. So the price here will be price, artist. We'll go ahead and put the title in there, and then we'll go ahead and put the art description in there. Still have that same image, but let's look at that in a moment. When we refresh this, we can see we're starting to get the different data that's underlying each of these, and that's all good. But let's go ahead and make another change here, and that is to show the image here. We actually have our images using this art ID. And so instead of just saying Van Gogh here, if we put it in parentheses, we can actually say at parentheses p dot art ID, and that will correspond with the art ID in the name. And so we're simply constructing a path, but it knows because of the way that we're constructing the razor here that we want the art ID. Now the parentheses are important here because otherwise, refresh this, we'll actually get an error because it doesn't know what to do with this. It doesn't know that there isn't a property on ArtID called .jpeg because we're trying to give it a clue about what is Razor and what isn't. And because we're putting the parentheses there, it's helping Razor figure that out. So if we refresh it yet again, we're going to see these giant images. Uh-oh, probably not what we really want, right? The images are larger than we'd like to be shown here. And so we can also fix that with another Bootstrap idea called image fluid. Now the images are the right size, but I don't like that they just seem to be stuck together. So let's come back here and let's wrap again all this stuff into its own div. And the reason I'm doing this is I want to be able to put in a class here that represents something that is going to show on the screen like a border. In fact, it's called border. And I'm going to make the background a little light gray, and I can do that with BG light. And I can even say rounded in order to make the border rounded. And lastly, I'm going to add P-1, which is going to tell it to give it a little padding so that all the contents are a little in from the border. Now when we refresh, we're getting this nice light outline, we're getting the gray background, and all of our content sits nicely in that. And so we're pretty close to what we actually want. The only other problem is, this being an image, we're going to want to also include an alt tag. We can do it in the same way. We can go ahead and use at p.artist or title. Actually, let's put title in there as the content we want to be in the alt. And if we refresh again, it looks the same, but if we right-click and inspect the element, we'll actually see that the element has that alt specified for us. So just because the properties aren't shown doesn't mean you still can't bind them with Razor. Let's next talk about logging. So now let's look at how we're going to log errors. If we go ahead and open up a console in our project, and I'm going to first just set the ASP.NET Core environment to development, just so you can see what it actually looks like when we run our application in development. When we do .NET run, We're going to see these info tags because logging is set up by default to write out to the console. So even on the startup of our project, we're seeing some information logging that's being added. An attempt to look up data protection keys in our project, and a framework core is showing that it's initialized our Dutch context. And most interestingly, here we have the select statement in our seeder that says select 1 for true if the number of products here exists. So this is the query that's generated from the query we did inside the code. If we start to go to individual pages and we go back to the console, you actually see a ton of messages. Every request to static files is being logged, every beginning and ending, so there's so much logging that's being done here. And that's useful, but maybe not helpful at this point. We can configure the level of logging directly in the configuration file. And so let's open up that config.json. Let's add a new section called logging. And we'll set up log level as a nested object inside of logging. And then we're just going to say default, let's say warning. This is going to tell it to use as a default level of logging is warning. And so a lot of those messages we saw should go away. If we stop this and restart it, you notice that a lot of those info messages went away. In fact, if we refresh the page, none of those messages were informative. And so they were all filtered out because information is lower than warning. Warning is only if something problematic is happening. So let's see what logging looks like in our own code. Let's go open up that repository. Let's inject a second member here called iLogger, and it's going to take as a generic argument itself. The reason for this, and I'm going to add the Microsoft extension logging namespace, the reason for this is the logger will then be tied to this type so that when it emits data, we'll actually be able to see where the logging came from. So I'm just going to call it logger, and I'm going to create a field for it. And when we call get all products, let's use the logger to log information. So we come back here and relaunch our project. It'll actually recompile it and then launch it. Let's refresh that page. And it's still working, but we're not getting any logging out here. And the reason is, like we did in configure.json, we told it that the default level is warning. But we can actually change this. Let's make the default level information, but tell it that for Microsoft, make it warning. What we're effectively doing is saying every logger that starts with the word Microsoft, use warning. So instead of doing that, we could actually say Dutch trait as well, because our logger, if you remember, this type starts with the word Dutch trait.data.Dutch repository. So you can use this as a way to filter it pretty well. I like to leave this as default and just change the Microsoft one to warning. Let's stop and restart it. And notice that none of the Microsoft info messages are being shown. But if I refresh our page and come back here, we'll see that our info message was actually added. And so generally, I leave the logging set up in this way, especially in development. And when I deploy the application to production, I change these log levels to something that's more appropriate. I also may add different logging so that I'm getting better log information stored someplace in a database or in a service or in files, whatever makes the most sense for your organization. But let me talk about what I really use logging for, and it's rarely for this sort of information. What I normally would do is put try catches here. And in the catch, I would use that logger to log an error. And here you can use the right line syntax, or I've become more friendly with that $sign syntax, so I can just include the exception there in my log message. And this would be a pattern that I would run over and over and over again for all of these methods. I'm not going to do all of them in front of you just for time's sake, but I would make sure that you're capturing these sorts of errors in logging so you can actually do something about them at runtime. Make sense? Let's wrap up this module. We've just scratched the surface of Entity Framework. If you want to go deeper, there's a couple of courses. There's an EF Core Getting Started, which you'll see at the URL below, taught by Julie Lerman. I suggest this if you want to get deeper into how Entity Framework works and how to maintain it for large code bases. What have we learned? I've shown you that you can use Entity Framework Core for data storage regardless of the type of storage you're talking about. I showed you how to use migrations to build the database for you. And finally introduced you to the repository pattern and showed you how it can support testability. Up next, let's create some APIs.